Hello everyone and welcome back to my channel. If you're new here, my name is Olakunle and I'm a site reliability engineer who loves sharing insights and tips on DevOps, cloud, SRE, and everything in between. So be sure to hit that subscribe button as we learn and grow together. In today's video, we'll be exploring Terraform scenario-based interview questions, ranging all the way from foundational concepts to more advanced techniques. If you're aiming for a DevOps or cloud role and notice Terraform in the job description, this is definitely the video for you. We'll walk through 20 questions that will equip you for real-world Terraform interviews. By the end of this video, you'll be ready to tackle Terraform challenges with confidence. We'll touch on essential topics like drift detection, multi-cloud deployments, and advanced lifecycle configurations. So stick around to the very end as there's a whole lot for us to unpack. And without further delay, let's jump right in. So an interviewer might kick things off by asking, what is Terraform and how does it work? You want to answer by saying something like, Terraform is an infrastructure as code tool developed by HashiCorp. It uses a declarative model allowing you to write concise configuration files that describe all aspects of your infrastructure, which could involve virtual machines, serverless functions, networking components, or entire application stacks. When I run commands like Terraform plan or Terraform apply, Terraform looks at my configuration files, compares them with the resources actually running in the cloud, and then either creates, modifies, or destroys whatever is necessary to align the real environment with what I've declared in code. In essence, I simply describe the desired end state of my infrastructure, and Terraform figures out how to make that a reality, ensuring consistency, scalability, and repeatability at every single step. Another question you're likely to encounter once the interviewer knows you understand the basics goes like this. What is a Terraform state file and why is it so crucial? You answer by explaining that Terraform state file essentially functions as Terraform's memory. It keeps a detailed record of every resource Terraform manages, storing metadata like resource IDs, configurations, and dependencies. Every time you run a Terraform plan or an apply, Terraform consults this file to determine which resources need to be created, updated, or removed so that your actual infrastructure matches what you've declared in your .tf files. It's also important to highlight that the state file can contain sensitive data like keys or private configuration details, which is why you should store it in a secure, remote backend with features like lock-in and versioning. This setup not only protects the file from accidental overrides, but also prevents multiple team members from making conflicting changes at the same time. By mentioning these precautions, you demonstrate your understanding of Terraform at a much deeper operational level, ensuring your interviewer sees that you don't just know what the state file is, but also why properly safeguarding it is essential. Another common scenario your interviewer might present you with is this. Let's say there's a resource in the cloud that was originally created outside of Terraform. How do you bring it under Terraform's management? You can answer by saying something like this. If I discover a manually created cloud resource that I now want Terraform to manage, my first step would be to write a resource block in my .tf configuration that mirrors the actual settings of that existing resource, essentially describing what already exists. Next, I'll use the Terraform import command, specifying the resource type, the internal Terraform name, and the real-world resource identifier from the cloud provider. The Terraform import command updates Terraform state file to reflect that this resource is no longer just out there unmanaged, but it's officially recognized and tracked by Terraform. From that point on, any adjustments to that resource, be it changing its tags, modifying its size, or even deleting it, will be done through Terraform, minimizing the risk of drift or configuration mismatches in the future. Moving on, Another question that often arises is, what if the Terraform state file accidentally gets deleted? How do you handle that? You answer by saying something like, if the state file is lost, Terraform essentially forgets all the resources it previously managed. If I've been using a remote backend with versioning enabled, such as S3 with versioning turned on, or Azure Blob snapshots, I'll simply roll back to a prior version of the state file. That restores Terraform's memory of which resources it has under management. However, if no backups exist, then I'll have to re-import each resource using Terraform's import so that Terraform can rebuild the state from scratch. This is exactly why it's important to follow best practices like storing the state in a version backend and maintaining strict operational discipline to avoid major headaches when dealing with accidents or oversights. Once best practices for safeguarding the Terraform state file are clear, the interviewer might pivot to how you handle diverse environments. They could ask, could you explain how to reuse the same Terraform configuration for multiple environments like dev, staging, and production? You answer by saying something like, one approach is to build modules containing the main resource definitions, then supply each environment, that is dev, staging or production, with its own set of input variables for things like instance sizes, region settings, or naming conventions. This way, every environment relies on the same code base but can adjust specifics using variables. Another option is to leverage Workspaces, which allows you to maintain separate files for each environment while still using the same .tf configurations. Both methods help to keep my code dry, consistent, and easy to manage, which is something interviewers value because it shows that you're thinking about scalability and structure from the ground up. After clarifying how to handle multiple environments, the interviewer might want to test your grasp of Terraform's fundamental commands. They might ask, what's the difference between Terraform Plan and Terraform Apply? You answer by explaining that Terraform Plan allows you to preview the exact changes Terraform intends to make, whether creating new resources, modifying existing ones, or removing those that are no longer needed without immediately committing any action. This preview step is critical because it helps you to identify potential issues or unintended consequences before they impact live infrastructure. Then, once you're confident in the plan, you can use Terraform Apply to actually implement those changes, bringing your environment into alignment with the declared state. Employers usually want to see that you appreciate how plan serves as a crucial safeguard, catching mistakes before they become permanent. Now that we've covered the essentials of Terraform, let's transition to a few intermediate level questions that often come up in interviews. A prime example would be, how do you collaborate on Terraform projects with a much larger team? You might respond by saying something like, when multiple people need to update the same Terraform configurations, I never rely on a local state file for anything mission critical or production related. Instead, I'll store the state file in a remote backend such as AWS S3, Terraform Cloud, or Azure Blob, so everyone can refer to the same authoritative source. I also ensure that state locking is enabled, which prevents two team members from running Terraform Apply at the same time and accidentally overwriting each other's changes. On top of that, I would often incorporate encryption for the stored state, as well as access controls or role-based permissions to ensure only the right people can modify or view the state file. This setup drastically reduces the risk of concurrency conflicts, accidental deletions, or data corruption, and it shows your interviewer that you appreciate the importance of maintaining a secure, collaborative workflow for Terraform in a multi-person environment. After clarifying how to manage collaborative projects securely, your interviewer might shift to a question about targeted resource removals. They could say, If Terraform has created 30 EC2 instances where you only need to remove a single instance, how would you do that without affecting the rest? If you want to explain that, you use the -target flag when running Terraform destroy, specifically the exact resource that you want to retire. For example, you'll run something like Terraform destroy -target equals to the address of the instance that you want to destroy. This instructs Terraform to only destroy that particular instance while leaving everything else intact. It's a vital capability for those moments when you need a partial decommissioning, perhaps because a specific server is no longer needed, while avoiding removal of other important resources. Now, the interviewer might shift focus to the crucial topic of secret management. It could pose a question like, how would you securely store database credentials or API tokens when working with Terraform? You want to highlight that it's never acceptable to hardcode sensitive information directly into the TF files or Terraform configuration files, or to commit such data to any kind of version control system. Instead, you explain that environment variables, HashiCorp Vault, or cloud-native solutions like AWS Secret Manager or Azure Key Vault are far safer options. If environment variables are used, you can set them at runtime so Terraform treats the input as variables and never exposes them in logs. In some workflows, you might store these secrets as workspace variables in Terraform Cloud or another CI/CD platform, further ensuring they do not appear in your code base. You could also mark any critical variable as sensitive within Terraform so the values aren't displayed in plan or apply outputs. By detailing these measures, you show you're not only thinking about convenience but also adhering to compliance requirements and best practices, a point that resonates strongly with anyone assessing your readiness for a security-conscious DevOps environment. Now that you have demonstrated you can manage secrets securely, the interviewer might raise the challenge of multi-cloud deployments. They might ask, how would you handle a situation where you need to create resources in both AWS and Azure within the same Terraform configuration? You explain that Terraform's provider-based model makes this relatively straightforward. In essence, you define multiple provider blocks, one for AWS and another for Azure, each containing its own authentication and configuration settings such as region or subscription details. From there, each resource block specifies which provider to use, whether provider equals AWS or provider equals Azure RM, ensuring that Terraform knows which cloud environment to operate in. You could, for example, spin up an S3 bucket and an Azure storage account all from the same set of .tf files. This approach is useful for organizations adopting multi-cloud or hybrid strategies because you maintain a single code base and consistent deployment process, even though the underlying resources might reside on different platforms. It also means you can keep your workflows uniform. That is, planning, applying, and version controlling your infrastructure changes in exactly the same way, regardless of which cloud they target. Once you've covered how to manage multi-cloud deployments, the interviewer might steer the conversation towards automation and best practices for scaling Terraform. They could ask something like, how would you integrate Terraform with a continuous integration and continuous delivery pipeline? Here, you would explain that you typically store all Terraform configurations in a version control repository such as Git. Every time a new commit is pushed, a CI/CD pipeline is triggered, starting with Terraform init to download the required provider plugins and prepare your working directory. Next, you run checks like Terraform validate to confirm your configuration syntax is correct. Some teams also add linting tools or even security scanners like checkoff to catch style or compliance issues early. After your configuration is validated, you produce an execution plan using Terraform plan. This plan outlines the resources that Terraform intends to create, modify, or destroy, and your team can review it, often requiring a manual approval for critical environments like production. Only once the plan is approved does the pipeline proceed to run Terraform apply, which actually provisions or updates the resources in your cloud environment. By detailing this workflow, you show that you understand how Terraform fits into a broader automation strategy, creating an end-to-end process that's versioned, reviewable, and auditable, qualities employers are keenly interested in when they talk about modern infrastructure as code practices. After covering CI/CD integration, the interviewer might bring up a concern about maintaining consistency within your infrastructure. They could ask, what happens if someone makes changes directly in the cloud console instead of going through Terraform? You would explain that in a well-controlled environment, you ideally restrict manual configurations in production, so no one should be tweaking resources outside the Terraform process. However, if manual changes do occur, you need a strategy for drift detection, which typically involves running Terraform plans on a regular schedule. When Terraform detects a mismatch between what's defined in your .tf files and the actual infrastructure state, it flags those discrepancies. You then decide whether to roll back the changes by reapplying your code, effectively overwriting any console changes, or update your configuration if the console modifications are valid and you want them to persist. The critical point here is that Terraform should remain the single source of truth, ensuring your managed resources don't fall out of sync over time. This approach highlights your ability to maintain order and predictability even when manual interventions slip through. Once the interviewer sees you understand how to detect and handle drift, they might dig deeper into how you keep your code organized at scale. They might ask, why use Terraform modules and what advantages do they offer in large-scale projects? You want to explain that modules serve as self-contained packages of related resources, variables, and outputs. This modular structure not only promotes code reuse, so you don't have to, rewrite the same setup multiple times, but also ensures consistency across the organization. For example, if there's a standard VPC layout, a specific tagging convention, or a well-defined S3 bucket configuration that every team must use, you'd encapsulate all of that logic within a module. Teams then reference that module rather than creating new, slightly varied configurations all the time. From a practical standpoint, this also makes version control more efficient. Instead of scattering similar code across multiple repositories, you could maintain a single source of truth in one place. When you need to update the logic, say to change default encryption settings or add a new resource policy, you could do it in the module and every environment that depends on it benefits immediately. This approach streamlines development, reduces the chances of error, and helps standardize best practices across your entire infrastructure. Once you've illustrated how modules streamline your code base, the interviewer might steer the conversation towards handling multiple instances of a resource. They could ask, when would you choose count over for each and vice versa? You want to explain that count is a straightforward way to create a fixed number of identical resources, like spinning up 5 identical EC2 instances. It's concise and it works well if you just want to say count equals 5 and don't need to differentiate among those instances. On the other hand, for each is ideal when you have a set, list, or map of items, with each potentially needing its own configuration details. For example, if you have a map of subnet definitions where each subnet might have a distinct CIDR block or tagging scheme, for each lets you iterate gracefully through that collection. And in doing so, you can access each item's key and value, enabling fine-tuned control over how each resource is provisioned. This distinction shows the interviewer that you know how to balance simplicity with flexibility when building out more dynamic infrastructure. Rounding up the intermediate level questions, your interviewer might ask, how do Terraform Workspaces help in managing different environments, and when should you use them? You want to answer by saying something like, Workspaces let me keep multiple state files such as dev, staging, and production within the same configuration directory. For instance, I would run Terraform Workspace new dev to create a development environment, then maybe Terraform Workspace select prod when I'm ready to work on production. Each workspace has its own state file, yet they share the same .tf code, so I don't have to duplicate configurations for each environment. It's a really neat way to keep your development, staging, and production states separate while still maintaining a single source of truth in the form of unified Terraform files. Moving on to more advanced questions, your interviewer might focus on how you minimize downtime in a production environment. So they could say, could you walk me through how you achieve a blue-green deployment using Terraform? You answer by saying something like, to ensure near zero downtime, I start by provisioning a fresh environment, often called the green environment, while the current blue environment remains fully operational. I rely on the same Terraform configurations I use for blue, but I adjust critical identifiers like resource names, network subnets, or autoscaling group labels to avoid conflicts with the existing infrastructure. Once green is up, I run a thorough validation process, which can include functional tests, performance checks, and security scans to confirm the new environment meets all requirements. After everything checks out, I switch traffic from blue to green using either a DNS update or a load balancer modification, which directs user traffic to the newly provisioned resources without causing downtime. Because the green environment is already active and validated, users typically experience no interruption during this transition. Finally, once I'm certain the cutover went smoothly, I decommission or repurpose the old blue environment by running Terraform destroy on those resources. This approach creates a safe rollback path, meaning if something unexpected fails in green, I can revert traffic to blue until issues are resolved. In practice, this blue-green method with Terraform drastically reduces deployment risk while helping maintain continuous availability. Once you've shown your understanding of blue-green deployments, the interviewer might shift to another advanced Terraform feature, Lifecycle meta-arguments. They might say, how do create before destroy and prevent destroy help in production systems? You answer by explaining something like this. These two lifecycle arguments are incredibly useful for managing critical or long-lived resources in a safe and controlled manner. First, create before destroy instruct Terraform to provision a new resource before tearing down the old one. This is especially important for updates in high availability environments, like rolling out a new version of an application server, because it ensures the replacement is fully operational before the existing instance is decommissioned, thereby minimizing downtime. On the other hand, the second argument, prevent destroy, is all about safeguarding crucial infrastructure that you never want to lose by accident, such as a production database. When this attribute is set on a resource, any attempt to destroy it triggers an error, effectively blocking the operation. This not only protects against human error or misconfiguration, but also demonstrates to stakeholders that you've put guardrails in place to avoid catastrophes in critical environments. In large organizations, these two lifecycle arguments can make the difference between seamless maintenance and unexpected outages or data loss. After covering how lifecycle meta-arguments safeguard production environments, the interviewer might press further on ensuring quality. They could ask, how do you properly test Terraform code? You can answer by elaborating as follows. I believe the testing process should happen at multiple levels. First, I run basic checks like Terraform Validate to catch syntax errors or Terraform FMT to ensure consistent formatting, right in my local environment or as part of an early pipeline stage. But for more in-depth scrutiny, I incorporate linting tools such as tflint or checkall. These tools not only check for stylistic issues, but also scan for potential security misconfigurations like overly permissive IAM roles or missing encryption settings. Beyond that, truly robust projects also incorporate integration testing frameworks like TerraTest or Kitchen Terraform. TerraTest, for instance, works by spinning up resources in a real cloud environment, then using Go tests to confirm they're functioning as expected, verifying network connections, services, and configurations. Once the tests pass, it tears those resources down, ensuring you don't incur unnecessary costs. Kitchen Terraform follows a similar pattern, running test suites against actual cloud deployments. Used together, these strategies allow me to catch issues early, confirm that each piece of infrastructure meets organization standards, and maintain a continuous feedback loop for infrastructure quality. After covering rigorous testing approaches, the interviewer might shift to version management and ask you, what do you need to do if you need to migrate from Terraform 1.5 to 1.10? You answer by saying something like, in a production environment, I can't just drop in the new Terraform binary and hope everything works. I'll start by reviewing HashiCorp's release notes to pinpoint deprecated features or syntax changes that might impact my current configuration. For instance, I'll look at provider blocks in files like main.tf or providers.tf to see if there are updated version constraints or new arguments. I'll also check any module references in my main configuration files to ensure compatibility with the new Terraform version. Sometimes I need to adjust variable definitions in variables.tf if Terraform has introduced or removed specific arguments or data types. Once I identify potential conflicts, I'll refactor those config blocks accordingly. After making these changes, I'll spin up a lower environment like development or staging environment to run a complete Terraform plan and Terraform apply. This step verifies that everything still behaves as intended under Terraform 1.10. If all goes well, I'll run Terraform init upgrade to pull the updated providers, verifying once again that my modules are in sync. Only after thoroughly confirming that no unexpected changes occur would I proceed to upgrade production. This cautious approach demonstrates that you understand version upgrades can be complex and that maintaining a safe, stable infrastructure requires meticulous testing and rollout procedures. Now that you've demonstrated how to handle version upgrades and maintain a robust infrastructure, the conversation might shift towards coordinating Terraform with other DevOps tools. The interviewer could ask, if we rely on Terraform to provision servers, how do we integrate Ansible for application setup? You answer by saying something along these lines. Terraform is great at creating and managing the underlying infrastructure like servers, networks, and security groups. Ansible, on the other hand, specializes in configuring what's inside those servers, whether it's installing specific packages, managing services, or deploying applications. One straightforward approach is a two-step pipeline. First, I run Terraform apply to spin up the necessary EC2 instances of virtual machines. Then in a separate stage, I call an Ansible playbook that installs software, configures services, and handles application deployment. This division keeps things organized, as Terraform owns the infrastructure layer while Ansible focuses on the application layer. Alternatively, it's possible to embed Ansible commands directly in Terraform using a null resource provisioner, although many teams choose to keep them separate for clarity and modularity. Either way, the key is letting each tool do what it's best at. Terraform handles infrastructure changes, Ansible handles configuration inside the servers, so you end up with a clean, reliable DevOps workflow. As we wrap up, I hope these 20 scenario-based Terraform questions, progressing from the most straightforward ideas to truly advanced techniques, have given you a clear view on how to handle a wide range of interview topics. Remember that context is everything in real interviews. Try to structure your responses using the STAR method, and don't hesitate to talk about actual projects where you've applied these principles. If you've watched this video up to this point, let me give you a pro tip. Always reference best practices like storing your state files remotely, enabling state locking, running automated tests, and reviewing your Terraform config changes through version control. This demonstrates not just technical know-how, but also a disciplined, security-focused approach. And if you want more hands-on experience, spin up a mini lab using a free tier account on AWS or Azure, break things, fix them, and truly solidify your Terraform skills in a real environment. Thank you so much for watching. If you found this video helpful, please like and subscribe, and let me know in the comments which question resonated with you the most. Also, feel free to share any topics you'd like me to cover in the future. I value your feedback and definitely want to create content that you find relevant. For those of you who have interviews coming up soon, I wish you the very best. I'll see you all in the next video. Bye for now.